Hello, my name is Pradul Bhattrai, and today I will be showing my final project. This project is called iWare, and iWare an AI-based portal trial e-commerce system for iWare retailers. iWare is a web platform that brings together three features in one product: a real-time virtual trial using your webcam, a face safe recommendation, and an eye health screening tool. Let me start by explaining why this project exists. The problems. The core problem is simple. Online eyewear shopping has fundamental flaw. You are choosing something you wear on your face, but you can only see it on that product image. This is the first problem. The customer gamble on how uh, the frame will look until it arrives and need to return, which is common nowadays. The second problem is that the buying glasses. There are a lot of places you can buy glasses online, but no convenient way to check your eyes. Uh, eyewear shop and eye health have always existed separately. The third problem is personalization. Existing tool might offer one of these two features, but no free product combined. Virtually try on frame recommendation and eye health screening in a single platform. These three gaps together define the opportunity for the our eyewear, which come to our solution. I will address all three gaps in one unified web application. The first feature is the virtual try-on using a webcam, media face, and OpenCV image processing. The system overlay glasses face on your frame on your face in real time at roughly 15 to 20 frame per second on a standard laptop with no GPU required. If I go here and try my try on, do a camera. No, because of recording here, I cannot show you, but let's move on to our. I will just explain how our feature work. Uh, the second feature is face safe recommendation. It captures a single photo from your webcam and analyze your face geometry using landmark, classifies your face shape into one of the five categories and recommend the most suitable frame styles. Yes, video still running. Yes, there is no delay on video. Thank you. And now, as for the third feature, which is our eye health screening. You upload a fundus image photograph or retinal image, and the system runs it through uh, train mobile net to classify to run diagnostic scores across eight retinal conditions from ODRK, ODIR5K dataset. Let's move on to our technology stack. The technology choice were relatively practical. For the front end, plain HTML, CSS, vanilla JavaScript, all of that common stuff. And no framework was needed at this scale. And keeping it simple meant the webcam API and face calls should be written clearly without building tools. The backend is Python, Flask, um, structure using blueprints, one for authentication, one for product, one for cart, one for order, one for the try-on pipeline. For computer vision and AI, the project use MediaPipeface, MES for landmark detection, OpenCV for image processing and alpha bending, and MobileNet V2 model with an efficient NetBio backbone for the IELTS classifier trained with PyTorch. The dataset is PSQL managed through SQL Alchemy ORM with five core table covering user, product, cart item, order, then order item. And with the help of OMR, I don't have to write my own raw SQL. Now let's move on to the system architecture. The architecture is a classic three-tier client server design. The browser handle the user interface, webcam capture, and all the user interaction. For the try-on and recommendation flow, the browser capture frame from the webcam encodes them as a JPEG and post them to the Flask server by fetch. And the Flask server receives these frames, which were sent on a JPEG, run the computer vision pipeline, and streams the processed result back to a browser as a JPEG image, which the frontend then display. As for the shop, cart, and order flow, the browser receives server countered the HTML pages from Jinja to template driven by SQL Alchemy query against PSQL. The three specialized endpoint are /try_on for the live overlay, /recommendation, /analyze the /analyze the space feature, and /I health or analyze for the Fondas classifier. Now let's move on to our try-on pipeline. Virtual try-on is the most technically complex part of the system. So let me walk through it step by step. Step one, the browser capture a frame from the webcam onto a hidden canvas element, encode it in the JPEG and at 480 by 360 pixel with a 0.82 with the 0.82 and then post raw byte to the Flask endpoint. Step 2. Now, Flask receive these bytes that were captured, decode them using OpenCV into a Bezier matrix, and resize the image by 720 by 540 pixel for the processing because that was how efficient model need. Now for the step 3, media pipe face mesh. Media face mesh run on the frame and return 480 3 media face mesh return on the frame and return 483 dimension facial landmark. The algorithm picks two of them, landmark 33 and 263, which are the outer corner of the left and right eye. Now let's move on to the step 4. From these 2 points, the system calculates the inter-eye distance and use that to scale the glasses image to the right side, right width. It also computes the Anatan angle between the eye point to determine the face tilt, then applies a rotation matrix using warp mapping to tilt the glass to match. And now to the step 5. The rotation glasses PNG is composed on the facial region using 4 pixel alpha bending. A soft drop shadow is rendered behind the frame to make the overlay look less pasted on, and feature alpha is remove the white halo that natively cut out the PNG product. And now for the step 6, the result is encoded as a JPEG and streamed back to the browser with which replace the live video feed with the processed result. The whole cycle repeat every 66 milliseconds, giving the 15 to 20 frame per second as a FPS. Now let's go about our AI features. The IF pipeline begins with a server-side input check. It requires the distribution of the uploaded image or real Fondas image having a characteristic of orange red dominance. If the image fails this check, it is rejected before even classifying. Before the classifier runs it, like selfies and just normal eye image, uh, we only to prevent from giving a nonsense output. The image that pass the check are resizes to 224 by 224 pixels, normalized to floating point value in 0 to 1 range, and passes through the MobileNet V2 classifier. The classifier was trained on a 2000 image subset of ODIRK with the classes. Weight applied to the address the dataset significant class in imbalance. Uh, Diabetic retinopathy and myopia together account for over a half dataset. The recommender work differently. The recommender, as for the recommend facet recommendation, it worked differently. It used media pipe in static image mode on a single capture photo from 478 landmark. It picked 10 key points. The top of the forehead, the chin, the cheekbone, and the jaws angle, and the upper forehead corners. Uh, from these From these, it computes three ratios: face width to length, jaw to cheekbone width, and forehead to jaw ratio, and map the result on to one of five facial shape: oval, round, circle, no circle, square, heart, and oblong. The output page shows the detected shape of style tip or and a filter strip of recommendation product from the catalog. Now let's move on to our result and evaluation. The system has evaluated against 14 function requirement and 8 non-functional requirement. All 14% requirement passed. Registration, login, log out, the catalog, card, checkout, order, history, other history, live try on, uh, live try on with photo mode, face recommendation, eye health checkup, and classification. Every feature works. As for one one on performance, the live try on run at 15 to 20 frames per second on a developer reference laptop and 20 to 12 to 15 per second on a slower device. The IELTS classifier is about 78% accuracy on held up test set. The recommender return a face shape that is agreed with the user of test person, giving a 75% recommendation. These three volunteer use completed a structured user test with the three tasks. It's all tasks were completed without assistance. Average time taken were 5, 3, and 4 minutes. The quality feedback includes the word fun and initiative and surprisingly accurate. Now, let's move to our last page, challenging and lesson learned. Uh, there are three challenges that are worth highlighting. The first was a dependency conflict with NumPy, which blocked the media pipe. The fix was to get NumPy with the same version level as our media pipe and using our OpenCV. The second was class imbalancement in the ODIRK pressure set. Diabetic dominated all the training data, which caused the early model to be biased on diabetes because of it having a lot of data than others. Only the model was showing everything on diabetic. The solution was to apply change weight during training and use moderate augment to balance exposure across conditions. The third challenge was fundamental limit of 2D overlay. When a user rotated their head more than about 30 to 30, the 2D glass image cannot follow correctly because uh, for the 2D, the user needs to be on a front-facing stand. The now move on to our lessons. The main lessons prototype early. As for the main lesson, prototype early. The first working demo was 30 line of Python and confirm the core identity before any time was spent on the front-end. At static image mode in MediaPipe was significant accuracy improved for the pre-request processing process, continuous video mode. Uh, Now for the conclusion, what was achieved in future directions. To summarize, iWare is a working prototype that meets all six original objectives. It delivers a real-time virtual try-on face recommender and fundus-based IL check. Features no that are not in a, all the three features in a single place combined, running on a standard consumer hardware with no GPU requirement. Looking ahead, the most impactful future improvement would be to work on a 3D rather than a 2D because depth in estimation for the better health tone tracking using 3D CNN-based face classifier to replace the geometry rule and a larger and more balanced Pandas dataset and cloud deployment to move beyond the local fast development server hosting. Thank you. Thank you for watching.